Hi, everyone. Welcome to another episode of the Scripting Them podcast. Today, I have a very special guest. I have Dave Thomas here. He's the co author of The Pragmatic Programmer and many other books as well. But The Pragmatic Programmer, in particular, is probably one of the most talked about and read books in our industry, probably one of the most recommended ones as well. And the crazy thing I just keep thinking about it is that it was published originally in 1999, if I'm not mistaken, and the thing still holds up. So that's crazy. So actually the question that I want to answer today is whether it does actually holds up today in today's AI-driven world or not. So, uh, Dave, thank you for being here. Please introduce yourself a little bit better than I did, and we'll get going with the questions.
Well, thank you for that. Yeah, I'm not too sure I can introduce myself better, but I'll try. Um, Name is Dave Thomas. My accent explained by the fact that I'm English, but I've been living in the States for 30 years now, so I don't actually have a country of home when it comes to accent. I have been programming for over 50 years. I kind of worked that one out a couple of weeks ago, and it kind of scared me. Um, but yeah, I've been programming out all sorts of stuff, and I still program every day. Um, for me, it's just a way I have of expressing myself that I'm not a musician or an artist, so I use code instead. Um, and I have opinions to some extent came about through experience, and to some extent just came about because I'm becoming crotchety in my old age, and I just like having opinions. Um, so that's really all I have to say about me in this case. I'm really kind of looking forward to this conversation too, because obviously I've been thinking a lot about AI and how AI impacts coding and everything else. And then when you suggested the idea that, well, maybe we could investigate how that ties into the pragmatic programmer, that's an interesting framework that we could actually use to maybe explore some of those ideas. I got to warn you, like I don't know any answers when it comes to AI. I don't know if anybody does, but uh, I'm willing to pontificate just like anyone.
Yeah, I mean that's what that's what we do anyway in the internet, right? We share
Right.
our opinions. Now, definitely, I think it's important to preface this that by making sure that everyone understands we're not experts in AI, but we are developers. You've been doing it for 50 years. I've been doing it for 20. We do have our way of seeing code, our way of seeing the practices that we've been doing and following for so many years, and even if you're not an expert, you have to have seen the change or seen how it's changing the industry, how the industry is changing based on this new technology. Is it hype? Is it actual revolution? I mean, I think we're still deciding that, but it's definitely something. It's definitely affecting us in a way. Um, and I think that the fact, and as I said on the intro, the concepts that you wrote about almost like 25 years ago are still things that people keep repeating to everyone when they write about best practices, like don't repeat yourself, keep learning because you're going to be doing that for your entire career. But now we have this new toy, this new tool that we can just tell it to do something and it'll help in that regard. It's not gonna be perfect, but it's definitely moving towards a lot of people saying moving towards replacing us, which I don't think it will. But I just want to have the opinion of the someone who actually came up with these terms or just apply them or explain them in a way that uh, left a mark in the industry. So let's start with the first question. Let's start at the beginning. So these concepts, these very basic concepts that you talked about in the book, do they still? How do you see them applying when we have AI now and machine learning that will code for us or will solve a lot of the problems for us, and we don't really need to even think about the quality of the code if we get a working result, or do we?
So I guess one of the first things I would say is that programming has never been about typing code.
I like that.
The amount of time you spend typing code is probably 10-20% of the time you spend programming. AI tools can type code quicker than you can type it.
True.
And so they definitely help with that aspect. And they also are very good at giving you a kind of food pellet kind of reinforcement in terms of, oh, here's another function, here's another function, here's another function. I must be doing really well. So I think that, but underlying it all, I think currently at least, we are still programming. And we are using these tools in the same way that a good editor makes you a more effective programmer, right? The better your editor, the better your IDE, the better your tooling in general, then the faster you can do stuff. It's always been the case that, at the end of the day, it's the quality of the developer and their team that determines the quality of the code. And a good team with good tools will produce good things quickly. A bad team with good tools will produce bad things quickly, And I think the same still applies here. And the reason is that AIs are not going to be, in the short term, I don't know what's
Yeah.
going to happen 2 years from now, but in the short term, AIs are not going to be solving the whole problem. They're great for, I need a REST interface that's going to talk to this API, and out comes a couple of hundred lines of boilerplate. That's fantastic. It is also, I think, too early for us to be able to say what the downside of that is. For example, right now, a whole bunch of code has been written automatically, and it's just finding its way out into the real world. What we don't have any information on is what happens then, right? What happens to the maintenance of code when it's being written by someone who didn't actually understand it in the first place? How do you go back in there and make a change and make sure that you actually are doing the right thing? Okay, so you just ask the AI to do it. Well, yeah, except they got it wrong the first time. So what are you going to do? So I think that's a risk that is not yet realized. We're too soon in the cycle to start having the figures to say, yeah, it got out quickly, but it took us 4 times longer to maintain it going forward. I don't know. I think also that one of the things you have to remember is the way the large language models work is fundamentally just statistical based on patterns that they've seen in the past. Yeah. Now, it's not as simplistic as those. I don't know if you've ever written one of those programs that goes through and looks for like n-grams in a
Yeah.
piece of text and then tries to reproduce the author's work, which actually works surprisingly well with Tom Swift books. It actually comes out looking like a Tom Swift book. But anyway, but that's all they're doing. All they're doing is they're saying, in the past, I have seen this followed by that, and therefore I've seen this and that. Maybe it's going to be,
Yeah.
thing 3, which means that they are really, really great at reproducing visions of the past. Not so good at inventing visions for the future. And a lot of the progress we're making in computing right now is inventing the future. And so it's, I think for a while at least, it's going to be still a human job to stick their neck out and take a risk and do something that hasn't been done before. And then, yeah, sure, get the AI to write the boring parts. I have never been one to think that programmers, it's like, eating your greens, it's not a question of doing the boring stuff and that makes you morally a better
Right.
developer. It doesn't, right? If you can get someone else to do that for you, whether it's an IDE or an LLM or whatever, do it. But don't forget that your value comes from doing things that are not expected, that are not routine. Your value comes from being able to invent and say, hey, what happens if we do this differently? Yeah. Or the customer says they want this, but you know what? My experience tells me that actually they probably don't. What they want is this instead. I want to go back to them and ask them, yeah, if all we're doing is blindly feeding so-called requirements into an LLM and waiting for code to come out, we're never going to get to do that. So and as like I say, I mean, the speed with which LLMs have hit the world and adapted, it's really just like what, a year and a half,
Yeah.
2 years, something ridiculously short. And already they have taken over a large part of the mind space of the whole world. It's almost like you cannot put a product out now unless you've got some LLM in it as well.
That's true. Yeah.
So I think it's too early to predict the downfall of programmers, but it's really also no different to back in the day when all programmers were assembler programmers, and someone invented higher level languages, which you could write one line that was equivalent to 50 lines of assembler. Oh, this is going to put us all out of business. No, it's not. It's just going to make you different programmers.
Absolutely. I 100% agree with everything you said. But I like that you already tackled the fact that LLMs are just a tool, just like your IDE, just like everything else. Because there are a lot of developers out there proudly stating that they've never used an LLM so far. To code, they do all of their code manually. Everything's written by them, and I'm here thinking, well, that's just dumb. Why wouldn't you use a tool that will make you faster? Not necessarily better, but at least faster. You can produce and iterate over the code much faster with less work. So what I understand is that you agree with that. You definitely see this as
Yeah, I
a
do.
helping tool. That's all.
Yeah, but I think there's actually it's kind of interesting because you kind of triggered something in my thinking here, because thinking back to my own use of LLMs in coding, and I have to admit that most of it has been with Copilot,
Okay.
which I understand is not the best, but I find that I turn it on when I know what I want to do, and when it is like, for example, I was doing some coding a couple of weeks back that included a state machine, and typing in the whole state table got to be really, really
Right.
tedious. So I turned Copilot on and I kept typing, and after a couple of lines, it worked out what I was doing, and it started filling in for me, and I'd have to correct it every now and then, and it got better and better. And by the end, it had produced a couple hundred lines of state table. And it had really, really helped out. It then actually went and wrote half the state machine as well, which I thought was pretty clever of it. However, I am pretty much certain that it would not have come up with the idea of using a state machine for this particular problem in the first place. So I turn off Copilot whenever I'm exploring, because I find it's just too tempting to go along with its
Right.
suggestions, And so I turn it off and I experiment. And if I find myself getting bogged down in minutia, then I turn it back on again. And it's really, really great at just like digging my way out. Or if I find myself, using an API I'm not familiar with, then it's as quick to ask it as it is to go search online for it. So I will definitely turn it on for that. But I don't want to rely on it to replace my own critical thinking, because I think the value that I bring to the coding world is my critical thinking. Yeah, it's not my ability to type 100
Right.
lines of state machine, but it's my idea to come up with it in the first place, And so I don't want to get to the point where it's just easier to turn up in the morning, open the editor buffer and say, make it so, and then have everything else happen for me.
All right. So that definitely, I agree with that, and I even I can relate to that feeling of, turning off your critical thinking and just going along with it. I've done it myself when I'm just, I have this app idea, and I'm like, well, I would like to develop the app, but I know it'll take me like a month. But if I just feed the right prompt to ChatGPT, it'll just give me an MVP in 2 days. So I'll just go with
Mm-hmm.
it. I'll fix it later. So for that, I definitely see use. But I also go back to the comment you said at the beginning, where you said, what happens with that when that code hits production, and then someone has to maintain it, and there's no one really wrote it, just the AI. No one really understands it, and that's what I'm going back now. I'm thinking, well, and now I have to read this code and understand the code as if someone else wrote it completely, because I didn't do it. And that's definitely a problem. Now, in that mindset, and we're just playing futurologists here, because obviously anything can happen. But how do you see the near future of our profession when um, you have this problem? When you have, I'm not going to say problem, because here's the thing: I think there is a big difference when someone like you or me, who's been doing it for decades, gets a hold of these tools and say, well, today I just want my brain to turn off. I'll just go with it, and then I'll go back. I can do it. I've been coding for 2 decades. I know I can fix the code if I need to. But what happens when someone completely new, 6 months of coding, grabs this tool and say, well, now I'll just turn myself on off because I don't really need to think. I'll just grab the code and put it in production. um, that person is that developer, 6 months of profession using LLMs, is going to eventually hit a year, 2 years, 5 years of professional developer using LLMs. How is that developer going to work, or how is our industry going to change when that happens? When the norm, the baseline, is just developers using from the first day these assistive tools. What do you think about that?
I think it's inevitable. I think it'll be a different industry, but I think it will be more effective than it is now. I think, again, come back to the idea that an LLM is not fundamentally different to an IDE in terms of the fact that it makes you more productive. It does a little bit of anticipation. It helps you when you need help. It's just way smarter. It has way more context. Let's put it
Yes.
that way, than your average IDE does. So I think learning to use LLMs is going to be an essential skill, right? And I'm pretty much guarantee that a modern developer who has spent a year, 2 years, 5 years learning how to work with LLMs is going to be a more productive programmer than I am
Using it.
using
Yeah.
LLMs. Yeah, because they will have that will be their entire experience, and that will be they don't have any preconceptions, they don't have any blocks. Whereas I might be a bit nervous trying to
Right.
use this or that. They'll just go, well, look, and 90% of the time they'll be right. So I don't have any problem with that. I think the industry is going to use whatever tools are available, and I think that those tools used responsibly would be just as good as any other tools that we've ever chosen to use.
Interesting.
The question you've got is, okay, what does used responsibly mean? And how do we know that we're using it responsibly? And for that, I don't really have an answer, but I know it's a question we have to be asking. Because if If all the developer does in the morning is log in and then type in the next 3 paragraphs of the customer requirement specification and let something generate the code, then first of all, what value are they
Right.
adding, right? And secondly, and more importantly to my mind, who's responsible for what they produce, right? Is they are submitting that code up into the repository with their name on it. Are they responsible for that code? Or if it doesn't work, do they just say Claude got it wrong? I mean, how do we handle that situation? Right? How are you going to do, 6-month reviews in a world where people are doing that kind of thing? And I think it's possible, but I think we have to think what
Yeah.
we mean.
Yes, definitely. And ownership of that is definitely going to be a problem. I think that. So I was going to ask you about learning about that developer who you said. I just want to go back a little bit to get back to this point, but so you said something interesting is that someone who grows up using these tools, these LLMs, and through their career, they're going to be much more efficient than we are at it, and that makes total sense. But at the same time, there's a set of fundamental knowledge and understanding that you have to have, or you should have, I guess, that you might just skip it because you don't need it. So when that happens, and now I'm going back to this point, is if you need to review the code at least to make sure that you own it, how will you be able to do it if you don't really understand the basics of how it works?
That's a really good question. Um, when I went to school, we had to learn our times table. We had to be able to do long division and all those other quaint, archaic things. Um, and pocket calculators were just coming along. And they did not have scientific functions or anything.
Right.
They were just plus, minus, whatever. Right? Nowadays, schools tell students what calculator they're supposed to use. And the idea of learning your times table is nowhere near as important as it used to be, because everybody knows you can go to your phone or go to your watch and say, hey, work this one out for me. Is that a loss, or is that just evolution?
That's a nice comparison.
And I think the answer is not
Yeah.
obvious. I think that to some extent, if you can go and get your phone and divide some number by another number, that's good enough. At the same time, I think that learning the basics, learning the fundamentals of arithmetic, gives you a feeling for numbers that you might not otherwise have. And it's really noticeable that my kids, for example, are not as good as estimating as we were when we were kids. They don't have that intuitive feel for numbers and magnitudes that we have. Will that be the same for programmers and LLMs? Probably. But at the same time, the world hasn't really stopped turning just because most kids can't multiply two-digit numbers in their head. It's just different. So what does that mean in terms of ownership? Not much more than it does right now. I mean, when you think about it, right now, we assume that the libraries we're using are correct. So we're writing, I mean, I don't know about you, but the average program I write is probably 1% my code.
Oh, yes.
And 99% library code, And so all that code I'm shipping, and I'm putting my name to it, right? 99% of it is not stuff I've written, it's stuff I've brought in. And does it ever have bugs in it? Of course it does, And my personal view is that when it does have bugs in it, it's my responsibility at least to work out what went wrong, right? I don't necessarily have the ability to fix the bug, but at least I can pin it down to, oh, that was a change made in MySQL, whatever it was, and then work out how to get around it. So I think if a developer is using LLMs and those tools are developing code, they have a responsibility to know that at some point in the future they can come back and examine that code for problems and fix them potentially. I think if you ask an LLM to produce code that you do not understand, then you are being unprofessional, right? It's a tool, and as any tool, you have to be part of the process, right? You don't just leave it to it and move on. And I think that's okay. I think that you can actually use, I use LLMs also to learn. So quite often I'll be doing something and I'll ask it to generate something, and it'll do something weird. I've not seen it before, it'll use some library function I've never heard of or whatever. And I'll go, oh, that's interesting. And then I'll dig in, and either it got it wrong,
Right.
or more likely I was ignorant and I didn't know about this thing and I just learned something. So I think if the generation that's just starting off, if they treat LLMs as what they are, which is fundamentally just a way of churning out some pretty plausible code, and then they use them as an opportunity to learn about that code, then they can rightfully claim ownership of what comes out because they're taking responsibility for what it does in future.
I like that. I like that. Keeping humans in the loop, definitely something that has to happen. Now, let me take you back to something you said at the beginning when you introduced yourself. You talked about code and your coding practice as an expression of yourself. You said, I'm not a musician, I'm not an artist, but I code. How do you see that craftsmanship, essentially, of your of code, of the us putting our fingerprints in the code in a way that we know we wrote that? How important do you see that? And in when that code is actually just auto generated by LLM, what will happen with that craftsmanship?
So I think there are a couple of aspects to that. Craftsmanship does not necessarily mean ownership. And so let's distinguish between the two. To me, ownership is about responsibility, right? So I produce code, I agree to be responsible for it. And I will not use the LLM wrote it as an excuse for bad code. So that's the ownership side. Craftsmanship is a question of knowing your tools and using them effectively to do something that you want to do. Yeah. So I do woodworking as kind of like a hobby. And woodworking is a really interesting domain because at one end, there are people that will only use hand tools, right? They will use saws and chisels and planes. And, the idea of plugging something in, no, that's not what a woodworker does. The average woodworker does a mixture. They will do hand tools when appropriate, but if they have to cut a big board, they'll feed it through a table saw, There's no point for them in getting, to be honest, the machine does it better than they would. So they'll do that. But the pieces they produce are still aspects of their own imagination. And it ultimately wouldn't have existed unless they did them themselves. So then, in the last maybe 10 years or so, the idea of having hobby level CNC machines. These are machines that typically have some kind of cutting tool on what looks like a big graph plotter. And you put a piece of wood underneath it and you program it, and it will go away and it will produce a very accurate, very repeatable cut. And in the industry, those are used for turning out pieces of repetitive work. So, if you want to make, 1,000 soup bowls, You just put a whole chunk of wood into one of these things and let it rip, and eventually out come your soup bowls. And there are certainly some hobby woodworkers who are doing that. They make their little pieces and they sell them at craft fairs. And you see these articles about how I made back my investment in 6 months using whatever, But there are also craftsmen and women who use CNC machines as just one more tool in their woodworking. Quite often they use the CNC to generate jigs that they will then use to make some other piece. So it will be some particular shape that needs to hold. So you'll make the CNC jig to hold that shape, and then you can work on it. Or they'll make parts of their final project using the CNC. And to me, those people are still craftsmen, because the CNC is for them just a tool, and it's just doing what their planes and their chisels and their saws were doing in the first place. It's just forming wood underneath their control. It's just doing it at a higher level of abstraction. I think the AI tools that we're currently using are a bit like those CNC machines, right? They can be used just to turn out 100 React programs. Yeah, I want a React program that does this. Here you go. Or they can be used as a tool that a craftsman use to help them produce something bigger. And so I don't think it's an either or. I think it's a question of intent. If you want to be a craftsman, craft person, you can do it. And you can use LLMs and not feel guilty, because you are using it in a controlled, intentional way.
Yeah, I understand. I like that comparison. All right, so definitely then you see, let's say, a bright future for developers. You don't see them being extinct, but rather slightly changed through their tools.
I think there will be some developers who are extinct, or who will become effectively maintenance programmers. But that's no different to the way it's always been. Developers who refuse to learn new technologies, new tools, rapidly become supernumerary, right? They are no longer needed, because that's not where the action is. Right. Now, there's a niche there. I mean, one of the highest paid jobs in programming is COBOL.
I was thinking about the same thing. Yeah.
But it's a niche, and that's not going to go away. But for the run-of-the-mill, I'm a developer, then you've always got to be learning, you've always got to be adapting, and you've always got to be taking on these new things. And LLMs are no different to anything else in that regard, right? Just turning your nose up them and saying, well, that's not real coding, that doesn't help you.
Right.
That particular tide is already up around your ankles. You're not going to be able to make it go away by just wishing it wasn't there.
Absolutely. So, saying that, do you really think that the concepts essentially that you talked about in your book on the Pragmatic Programmer, will they stand the test of time, at least in the near future, 5-10 years? Will they resist or hold true even through this AI transformation that we're going through?
I think so. I mean, there are some interesting unknowns, I guess. Because my initial answer to that question, my stock answer is, well, the Pragmatic Programmer book is really nothing more than common sense.
Absolutely.
Right? I mean, there's nothing, it's nothing revolutionary. And it's not particularly prescriptive. It doesn't say do this, don't do that, most of the time anyway. It's really just saying, these are good ideas, good ways of thinking about things. And it's relatively tool independent. So I think the techniques in a pragmatic program, 90% of them would apply if you were an assembler programmer in 1970. or if you were a C programmer in 1980, or if you were, an LLM programmer in 2024, whatever. I think the same concepts will be valid. The slight doubt I have about that is that some of the underlying values in the book, or some of the implicit values, I guess, are to do with things like the value of time, the value of developer time, the idea that you don't want to waste time chasing down bugs, for example, because you duplicated something. Right. And that's a noble principle, but doesn't necessarily apply anymore if that chase becomes free. If you can say to some model, okay, I screwed up. I didn't realize that the sign function could produce negative numbers, right? And I probably use it 50 times in this piece of code. Could you go through and fix
Right.
it for me? If it can do that, then maybe the idea of dry is not important anymore. In fact, a lot of the idea, if what you're going to do is to devolve the responsibility for what counts as low level away from just lines of code into whole programs. And if you're saying that my tool is now responsible for that 1,000 lines of code, then the priorities change. And therefore, the stuff in the Pragmatic Programmer probably, I don't know what percentage, but a decent percentage of it becomes obsolete.
Okay, that's an interesting way to look at it.
Well, it's depressing from my point of view. And to be honest with you, until you asked that question, I hadn't really thought of it that way. But I think in any book like that, any book that talks about practices, there's always going to be some implicit values, that drive those practices. And if LLMs change the value proposition, then a whole lot of what we teach nowadays will not be relevant anymore.
I guess you can look at them as a higher level abstraction as well. And so when we jumped from assembler to C to Java, we stopped thinking about, or most of us at least, stopped thinking about processor records, right? Registries.
Mm-hmm.
We no longer, they're still there. We just don't think about them because that's not a problem we need to worry about anymore. Maybe this is the same effect essentially.
But that's a really interesting issue. I kind of agree at the register level, because modern compilers do register scheduling way, way better than I ever could. So that's yeah, I agree. But there are low-level things that you learn when you're an assembler
Yes.
programmer, for example, that will bite you in Ruby if you don't know about them. My favorite one is something you could do in almost any language. Allocate a big buffer, like how much memory you've got, half of it, allocate a big buffer, right? And then write code that goes through and initialize it with just like ones or something, doesn't matter. Then write code that goes through and adds up all of the numbers in that buffer. Okay. And do it two ways. First of all, add up the numbers sequentially, starting at the front of the buffer and just go index plus 1, index plus 2, all the way to the end. Time that. Then do the same thing, but skip by do 1, 1,000,001, 2,000,001, 3,000,001. Then go back to 2, 1,000,002,
Okay.
right? Time that. I can guarantee you the second one will be probably 3 to 5 times slower than the first, right? Why? Now, if you don't know how computers work, if you haven't learned about locality and caching and paging and page lookup and dirty flags and all that kind of stuff, it will be a mystery, right? But if you do know how that works, it means you can write more efficient code, even in a high-level language like Ruby or Java or anything else. You know, the same thing goes even more when you're writing code that's going to run on a GPU,
Right.
right? How do GPUs actually work? Right? If I'm going to write some code in CUDA or whatever, how do I know I'm actually going to get this thing efficient? Right? Simply writing in a parallel language is not going to do it. You have to understand what's actually happening, you know? And again, I think that's an area where developers don't do themselves any favors. You know, that if you don't understand some of the principles, and I'm not saying you have to be able to write risk
Right.
assembler or whatever, right? No one in their right mind would want to do that. But understanding even things like what's the difference between a risk machine and Intel machine, right? Um, where do they overlap? What are the characteristics of level 1, level 2, level 3, level 4 cache? You know, how does that all work out in terms of what a programmer does? Um, and I think those things are still fundamental, right? And I understand that they are so far removed from what you do day to day as a programmer that they may not seem like they're relevant. But ultimately, we are still bound by physics. And understanding the actual laws of physics actually really help when we're designing rocket ships.
All right. I can see that. I guess then it's a question of how often is it relevant? Like you said, maybe in my day to day, I'm coding a website. I don't get to think too much about that, the effect of L1, L2, L3 cache has on
Mm-hmm.
my code. But then again, maybe if I'm writing something that is mission critical and I need the extra performance, then definitely that would be something I actively look up and actively worry about. So the question is whether or rather what kind of concerns we'll have in the next 5 years with these tools doing a lot of the work for us will and also the evolution of the hardware, because the faster these machines are or the more powerful they are, the less also we have to think about the restrictions that they impose. We're no longer thinking about, I have what was it, 640 kilobytes of memory, to
Ha!
put all my code into. uh Now
Yeah,
I don't think about the memory anymore. You know what I mean?
sure.
So maybe
Yeah,
it's going to be the same abstraction.
maybe. Two answers to that. One of them kind of slightly tongue in cheek, and one of them isn't. The tongue in cheek one is today, my phone probably has more processor capability than all the computers in the world in
True.
1965.
Yes.
Um, Alan Kay, his initial Smalltalk implementation ran on a 16 kilobyte machine. Operating system, drivers, Smalltalk, display, everything, 16
Right.
kilobytes. Um, Nowadays, it would be 16 gigabytes to do exactly the same job. And you go, well, who cares, right? Moore's law makes this free. We can just do that. But the reality is that writing bad code, writing code that uses a lot of CPU and a lot of memory simply because it's available, you're also burning through one hell of a lot of power to do that, you know? And we are squandering so much energy by writing sloppy, big, slow, bulky programs that we don't have to be spending. At some point, someone is going to notice. I have no idea what the relative carbon footprint of computing versus, say, airlines is. I know airlines are about 4% of the world's carbon emissions. I would be amazed if computing is less than twice that. So we are using a significant part of the world's energy resources badly. Why has nobody called us on that? So that's one aspect to it. The other aspect is that even if you don't worry about that side of things, there are still low-level things that will affect you even if you've got the world's fastest processor and an infinite amount of memory. A program that becomes exponential in time is not going to run anywhere, right? I mean, sure, I can get away with doing, Fibonacci of 50 on a really big machine and Fibonacci of 30 on a really bad machine. But if I say to you, do Fibonacci of
Yeah, you're
100,
not gonna.
sorry,
Yeah, yeah, yeah.
it'll
Yeah,
never
yeah.
end, right? So you have to understand some of that stuff. Another one, which is a really low level issue, but if you don't understand it, it will bite you, is garbage collection, right? I had a piece of code a long time ago that was taking a large database query and generating a CSV file from it. Yeah. And by large, it was probably about 1,000,000 rows and maybe 15, 20 fields a row. And my code kind of ran okay on my test data, ran okay in production for a little while. And at the end of about 6 months, it started timing out. And I brought it back down and ran it locally. And sure enough, when I ran it on that data set as it currently was, it was taking 2 minutes to go through and produce the CFL. And so the HTTP request was timing out. And I looked at this and I was totally embarrassed. But what I was doing was I was taking my data field by field, converting each field into a CSV field, and appending it to a string. And so what happens is I get exponential time garbage collection, right? Because the string keeps building, runs out of space, has to copy it all to somewhere else, right? But the space that's left is too small to reuse the next time. So yeah, it basically is spent its entire time juggling memory. If I change that code to just append each field to a list as an independent field, and at the very end, join that list together, it runs a sub-second.
Right.
Yeah. That's the kind of thing that unless you're looking for it, unless you
Yeah.
understand, like, garbage collection is a thing, it's not just like a convenience, it's actually a tool, and that tool has certain parameters and characteristics. And if you don't know that, then you could be scratching your head and looking at this code for
Yep.
months, you know? Hey, maybe we should run it on a GPU. Maybe then it would work faster. You know?
That's fair. Absolutely. Absolutely. Okay, so with that,
See, now I'm sounding like the old man, you know. Kids these days, they don't understand what, you know.
well, but you bring very good points. I mean, I'm trying here to say, yeah, those things don't matter anymore, and you can come back with examples that are very practical and very real. So you tend to be right about that. At least you sound like you're right, and you're scaring me a little bit.
Well, that's a whole important thing, I
Yeah,
think. You know,
yeah.
sound
Yeah,
good. It
yeah.
doesn't matter who you are or not. Yeah.
All right. So with this in mind, then how do you see then the curriculum of a developer evolving, or what does it look like in the future for us in terms of what do we have to worry about, or does it change at all in terms of what do we have to study, what do we have to focus on learning when we're getting started and growing as developers? Let's put it that way.
Sure. So I guess my first question would be, what is a developer?
All right.
You know, I think one of the questions you have to ask is, if you want to get into this field, what is it you actually want to do, right? Um, do you want to write code? Is your passion, actually sitting down and writing lines of code? There will still be a need for people to do that because there are. I mean, if nothing else, how do you bootstrap the LLMs unless you have someone to write code? So there will always be some requirement for that. Um, Low-level device drivers, this kind of stuff, whatever it might be. But if that's all you want to do, you have to be conscious of the fact that that particular segment of the industry is going to start shrinking. I think, though, most people become developers because what they like to do is to create things that other people can use, right? The thrill of seeing some random person you've never met using your software it's hard to describe. It's a really cool feeling. If that's why you're a developer, then that's not going to go away ever. It's going to change, but there is still the need for a human in the loop to interpret and to deliver and honestly to delight, right? It's the human element that causes the little surprises. They go, oh, that's really cool, they thought of that, or whatever else, that I think is not going to go away. So if I was starting off my career right now, I would still be very happy to know the kind of low-level things I do. But I would be positioning myself as I'm not someone who writes code. I'm someone who delights my customers. And I have a whole range of tools I can use to do that. And, talk to me and we'll work out which ones are appropriate. Right. The other thing I would say is if you're just starting out right now, when I started out, I think it was possible to know just about all of computing. Right? It was a relatively small subject. Nowadays, that's just not possible. Never was. It never is. And so you have this issue of what do I focus on and how do I apply my time? The amount of time we have to do pure learning is relatively limited. So how do I use that time wisely? And I think my advice to a developer starting out now would be to try to look ahead at the things that are different to what we're doing now, not just the things that are incrementally better, right? So right now the battle is who's got the best LLM, right? And everybody's competing for the size of the memory and the amount of context it can keep and the quality of the solutions, blah 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 blah, and they're just leapfrogging over each one of them, right? There is no point whatsoever if you're a developer in constantly tracking that, right? If you use Claude and you're happy with Claude, then stick with Claude for a while, right? And do not use any of your valuable time chasing after these other unicorns. Instead, say, okay, so what else is coming along that is different to what I'm doing now? And it might be computing architecture. It might be to do with distribution. I think that's a really big area that's coming up. I think the idea of function clouds is going to be massive. And I think anybody who wants to be a developer 20 years from now is going to have to learn how to handle clouds of millions and millions of independent communicating functions, right? And that's going to be part of the future. All that kind of thing. Programming languages, ignore them, right? They're just like, unless they are totally, totally different. But for the average run-of-the-mill, Rust and Go are equivalent, right? They're very, very different, but so what? Right. They both address Van Neumann architectures, and none of them have any really original ideas in them. So, learn one, learn them all. But I would definitely, if you don't currently have one, learn a strongly functional programming language, because I think that it will be the future. Learn about distribution schemes and how they handle concurrency and mutability. Learn about architectures, learn about resilience. You're going to be looking at systems that never stop, systems that grow on the fly as people use them, all of those kind of things. So keep an eye open for all kind of apparently weird researchy topics that actually are totally different to anything you come across. And just bookmark it, just read it quickly, bookmark it, and then move on. because I think the future belongs to people who actually live in it,
Like that.
and so you can't just live in the past.
I mean, I don't think there is a better way to end the episode than that answer, to be honest. I had more questions, but they're just going to spoil that one. So I'm just going to end the episode here. Thank you so much, Dave. That was a fantastic conversation. I really, really enjoyed it. I think I learned a ton, actually. So that's it. Thank you again. And please, the last thing I'm going to ask you is to share where people can find you online if they want to reach out and ask you about things.
Oh, so my personal onlineness is pragdave.me. That's pragdave.me. And my kind of more businessy side is Dave at pragprog.org. And I actually run an open calendar, which is calendly.com/pragdave. And so people want to chat, they can book a slot there and we can chat.
Awesome. I'll make sure to add all those links to the show notes so people can reach out. All right.
And can I
Yeah,
just say, I
absolutely.
mean, you say you learned a lot. I also learned a lot. So that was,
Awesome.
for me, this has been a very enjoyable talk. So
Thank you. I really appreciate that. All right, folks, that's it. Thank you again, Dave. Thank you for listening, everyone else. And we'll catch you on the next one. Bye.
Bye.
And that was it for this episode of the Scripting Them podcast. Thank you so much for listening. Remember that you can find me online on Twitter at TheLeadman123. And you can also find the podcast YouTube channel just searching for the Scripting Them on YouTube. Thank you again, and catch you on the next one.